All right, this is lesson 7.4, task 3. So graph cube root functions. Analyze the effect of transformations on the points -1, -1, 0, 0, and 1, 1 on the graph of the parent cube root function f of x equals cube root of x. Identifies 3 corresponding points on the graph of any cube root function. All right, so like before, we had 2 points that we looked at. Now we're going to look at 3 points on a cube root function. All right, the cube root function of the form g of x equals a cube root of x minus h plus k. Make sure you have this written down. This is important, and this should look familiar. The mappings are -1, -1 goes to h minus 1 and k minus a. Again, you need to know these. And then 0, 0. That's kind of like that's your middle point here. That becomes your HK, which I call vertex. In this case, it's not really your vertex, but it's the center of your graph. And 1, 1 maps to H plus 1 and K plus A. So again, you need to know that, how those are going to map to new points. For cube root functions, the form g of x equals the cube root of 1 over b times x minus h plus k. The mappings are -1, -1 goes to h minus b and k minus 1. 0, 0 is still your hk, and 1, 1 will go to h plus b and k plus 1. Again, make sure you know these. You will need them. All right, third, sketch the graph of g of x equals the cube root of 1/2 times x minus 4 plus 1, using transformations of the graph of f of x equals the cube root of x. All right, step 1, identify the values of b, h, and k. So it's 1 over b, so your b is 2. H is 4, because it's x minus h, and then plus k, so k is 1. Determine the mappings for -1, -1, 0, 0, and 1, 1. So we know 0, 0 goes hk, so that's going to be 4, 1 is what 0, 0 goes to, so that's the easy one, the one in the middle. And then the -1, -1, remember it goes h minus b and k minus 1. So h is 4 and b is 2. So 4 minus 2 is the h minus b. 4 minus 2 is 2. And then k minus 1, k is 1. 1 minus 1 is 0. So that's where the 2, 0 comes from. And then we also have to find the point 1, 1. What does it map to? So it maps to h plus b. H is 4 and b is 2, so 4 plus 2 is 6. And then k plus 1. K is 1 plus 1 is 2, so that's where the 6, 2 comes from. So now we have 3 points to start graphing with. All right, so it says, how does the mapping of 0, 0 identify the translations of the parent graph needed to graph the function g? All right, so the change in the x-coordinate identifies the horizontal. X is your horizontal translation. And the change in y-coordinate identifies the vertical translation. Therefore, the graph of g is a translation Let me look at the equation again. So it's going to be -4 means I move it right 4 units and up 1 unit. All right, it says determine a few other points on the graph of g. The value of k indicates that the graph shifts 1 unit up. 1 unit up is a vertical movement. The points -8, -2, and 8, 2 are on the graph of the parent function. All right, vertical is your y. So this is your x, horizontal, vertical is your y. So due to the 1 unit shift up, the corresponding points on the graph of g will have y-coordinates of -1, 3. So -2 moved up goes to -1. 2 goes up 1 goes to 3. Use those values of y to determine their corresponding x-coordinates in the function of g. All right, so we're given the y coordinates, and we have to plug them in for g of x or f of x. So you're going to plug those in here and solve for x. All right, so when you plug in -1 and you crunch out the numbers, you get x equals -12. When you plug in 3, okay, to your y value or f of x, and you crunch the numbers, solve the equation, and you get x equals 20. So that means -12, -1, -12, -1 is 1 point, and 23 is another point. So we already found the first 3 points. We found the first 3 that were given to us using these right here. So we found the -1 maps to 2, 0. We found 0, 0 maps to 4, 1. And we found 1, 1 maps to 6, 2. So we took those 3 here, and then we found 2 more points. So now we have 5 points to graph. All right, then it says draw a smooth curve through the points. So this is how you would graph using your equation if you didn't have a calculator to type it in. All right, so we're going to graph the 2, 0. There's 2, 0. 4, 1 is here. 6, 2. And then -12, -1, and 23. And you can see that it is a continuous curve here. It has arrows on both sides to show that it is continuous. How can the graph be used to verify that the correct transformations are shown? All right, so the 0.41 shows a translation 4 units right and 1 unit up when compared to the 0.00. All right, the rate of change from 4,1 to 6,2 on the graph of G shows a blank by a factor of, when compared to the rate of change from 0, 0 to 1, 1 on the graph of the parent function. All right, so it's asking us what the rate of change going from here to here is compared to the parent function. Okay, so it would be a horizontal compression. All right, so it's a horizontal compression here by a factor of, remember it's 1 over b, but the factor is 2. All right, and if you need to go back and look at the previous task where it had the transformations, the information on that. All right, that's all for task 3. If you have any questions, please let me know. Lesson 7.4, task 4. Write a cube root function for a graph. Given the graph of a cube root function, you can determine the parameters h, k, and a or b for the function by considering the mapping of the points -1, -1, 0, 0, and 1, 1 on the parent function to their corresponding points on the given graph. All right, so you can find the parameters h, k, and a or b. So it's going to have an a or b. All right, so the point hk is the mapping of 0, 0 on the parent function, as 0, 0 is the point of inflection where the curvature of the parent graph changes. hk is the point of inflection of the transformed graph. Parameter a can be determined by examining the vertical change from the point hk to the point h plus 1 and a plus k, if that point is identified on the graph. Parameter b can be determined by examining the horizontal change from the point hk to the point b plus h and k plus 1, if that point is identified on the graph. Number 4 says write a cube root function with parameter a for the graph shown. All right, so we've got this graph here, and we can see that the point of inflection right here is hk, so that's -2, -3. So h is -2, k is -3. To find a, observe that the x-coordinate of the point -1, -7, so that's the point right below the point of inflection, -1, -7 equals h plus 1. So you can write it as mapping of 1, 1 on the parent function. All right, so 1, 1 maps to h plus 1 and a plus k. So -1, -7, that's this point right here, okay? So a plus k equals -7, okay? So -7 is here, and it just says a plus k equals the y value here. Well, we already know k equals -3. So if we plug -3 here, add 3 to both sides, a is -4. All right, so now we know a and we know h and k. All right, can the value of b be determined? Well, remember up here it said that it's going to have an a or a b, not an a and a b. So an a or a b. So I'm going to say no, this cannot be determined since we already have an a. All right, and it has a little bit different explanation here you can read. The equation of the function has the form g of x equals a times the cube root of x minus h plus k. Using the values of a, h, and k, the general function is g of x equals -4 cube root of x plus 2 minus 3. What transformations of the parent function created the graph of g? Select all that apply. All right, horizontal. The horizontal movement here is opposite the sign. So it's +2, so I know it's going to go left 2 units. All right, this is a -3, so I know it's going to go down 3 units. All right, this is negative, is outside, so I know it's going to be a reflection across the x. And then it has a vertical stretch by a factor of 4. All right, that's all for task 4. If you have questions, please let me know.